Yeah, ours says 75.
Does it?
Yeah.
Yeah, it does too. Is everything else the same? 30%? Yeah, it is. Sorry, let's change that then to, that's quite easy to change. 75-degree conductors, correct. Thank you for that observation. 460? 75-degree termination? That's what you guys have? Okay. All right, not unlike yesterday, we're going to solve for the same variables that we looked at yesterday. The difference is how we calculate some of the conductors and the overcurrent devices. There's some minor differences. Now, resistance welders are not near as common as your transformer arc welders. They actually are very much, specialized to welding shops. And for that reason, you're probably not going to have to do many of them, but it's important you know how. Now, some things to point out. First of all, the type of duty that we're dealing with down here. Okay, so the duty cycle, again, is going to help us determine how we actually size our branch circuit conductors. And so we're going to get into that. We're going to start with looking at our branch circuit conductors first and foremost. So I'm going to bring up a new sheet here. And we'll do some math. So, number one. Branch circuit conductors. We're going to deal with welder 1. What's the first thing we have to do if we want to figure out our branch circuit? We need current, right? So in this case, we're going to take 100,000 and divide by 460 volts. Now, why are we dividing by 460 and not 480? If you guys remember, everywhere else in the code book, when we're dealing with divisors, we have to go to Rule 8 and look at the divisors in the first part of Section 8. And usually the answer is we use 480. But I want to point out a rule, and that is in Section 42, when you look in 42-002, and you look at some of the terms that they put there. One of them says rated primary current. And rated primary current goes on to say that we will use nameplate values divided by the rated primary voltage shown on the nameplate. Rated. Okay, so unlike other loads in the code book, we actually do divide by 460 here, not 480, because that's our rated value. So if we do that, it should give us 217.39. Now, what's our multiplying constant as far as the fact that we're dealing with non-automatic variable duty? Here's where we go to 42006, or sorry, that's wrong one. 42002, right? And we have to go through and look to see what our G rating factor would be. That's for the controller. Oh, that's motor generators. Let's try it again. 42014. So we're looking for 42014 here, you guys. Let's do this. So this is 42014. I was looking at motor generators, looking at everything but resistance welders. Okay, and it says that we're going to multiply it by then 50%, given the duty. So times 0.5. And if we do that, that should give us 108.7 amps. We go to table 2, and that'll give us a number 2. Just double check that because I did change it to yours is 75 degrees. Let's double check if that's okay. So we're looking for 108. Yeah, so I did use a 75-degree column. I just didn't catch the 90-degree on my sheet, but your sheet does say 75 degrees. Good. All right, welder 2. We have 75,000. And again, we're going to divide by 460 volts. 163.04 amps. Whoops. Multiply that. What's our multiplying constant in this case, given that we are automatic feed variable duty? 0.7, good. And gives us 114.13. And that again equals a number 2. And again, I'm going to put in here at 115 amps because we're going to need to know that number here in a bit. Okay. Welder 3 is a 50,000 VA divided by 460 volts. 108.69. And our multiplying constant, given that that one is a 30% duty cycle, should be 55%. 59.78, which equals a number 6, and that's good to carry 65 amps. So if we go back over here and write some of these in, so our conductor here is a number 2, number 2, and number 6. All right, that's our branch circuit conductors. Let's look at our branch circuit over current device. So for our branch circuit over current device, we'll go back to the rules. And we're going to look at 42016. That's going to tell us how we come up with our overcurrent devices. All right, now this is again very much like transformer arc welders. We have 2 calculations we need to complete here in order to make sure we get the right accuser breaker. We can't be more than 300% of the primary current of the welder, and we also can't be more than 300% of the wire of what it carries. Although just like transformer arc welders, we're allowed to go up to the next rating as long as we don't go past 300% of the primary current. So there's 2 calculations we're going to take a look at. And this gets interesting because you're going to see that we end up having 2 overcurrent devices that are the same size. So when we go to the feeder, there's a certain method that we have to follow in order to get it right. So let's look at welder 1. So we take the full load current, which is 217.39, times that by 300%, and that gives us 652.17. Now, no matter what, we can't go past that number. So clearly, we would go down to a 600 amp overcurrent device based on table 13. We just use it as a catalog. But don't forget, we have a second calculation. We have to take 115 amps because that's the ampacity of the wire, and we can't go past 300% of that particular number. And that gives us 345 amps. However, if you look at 42-0162A, it says that we're allowed to go to the next nearest rating if this doesn't work out to a standard rating of fuse or breaker. They don't make a 345 amp breaker. You can find that in table 13. Therefore, what they're saying is we're allowed to go up a size as long as we don't go past actually 652.17. So in this case, we can actually go up to 350 amp breaker or fuse. There's the device we select for that particular welder. All right, whoops. Let's go back to black. Welder 2. Again, we're going to take full load current, 163.04, times that by 300%, and we get 489.12 amps. We can't go past that. So if we go to table 13, that would equate to a 450 amp device, breaker or fuse. But once again, we can't go past 115 times 300%. That's the ampacity of our wire. So that gives us 345 amps. However, we're allowed to go up as long as we don't go past 450, which equates to a 350 amp over current device. So you can see right now we have two of them that are the same size. That's not uncommon. Welder 3, full load current, 180 or 108.69 rather, times 300% is 326.07 amps. Again, going to table 13, that would equate to 300 amp user breaker. Second calculation is 65 amps, which is what a number 6 can carry, times 300%, giving us 195. Do they make a 195 amp breaker or fuse? Does table 13 say that that's something that's available or manufactured? No. So we're allowed to go up to 200 amps. Here's the device we select. Okay, before we move on, any questions on how we came up with these? Because I know that one rule really makes a lot of students stumble as to how to go about calculating this overcurrent device.
So when you're basing it off the conductor, you just go, you're allowed to go up the ampacity of the next one. But then if you're basing it off full load amps, you have to go, you might exceed that, so you have to go down to the next one.
That's correct.
Okay,
Yeah, it depends which one is smaller. So again, the rule says that in the case of 300%, no matter what, let's put it this way, no matter what, you can't go past that number right there. Whatever 300% of your primary current, doesn't matter what it is, you can't go past that number. So if 300% of your wire works out to be more than what 300% of the full load current of the welder is, then that second calculation is almost null and void because you can't go past this number no matter what. All right, so where it gets a little trickier is when, and this is most often the case, when you actually have a situation where 300% of the ampacity of your wire is smaller and doesn't work out to a nice pretty number in the sense that we don't have a device, like they don't make a 195 amp breaker fuse. It says we can go up a size as long as we don't go past this magic number right here. Right? So that's why you have to always complete your due diligence and do both calculations, because you may run into a circumstance where, and more often than not, you're allowed to go up a size. And a lot of students get caught here. They'll look at that and they'll say, okay, well, I'm going to select a 175 because that's the next nearest rating. Wrong, because the rule says that we can go up a size as long as we don't go past 300% of whatever the full load current rating is of that welder. Okay? Good. All right, so now let's take a look at the feeder conductor size. Actually, I'm going to go back and I just want to put these sizes in here so we can keep track. So here we have a 350 amp, we have a 350 amp, and here we have a 200 amp. Okay, there's our sizes. Now, if you guys read the rule that talks about the feeder conductor size, okay, I want you to look at 42-014, item D, and items I, or 1 and 2, rather. Okay, it tells us how we go about sizing our feeder conductors. So 3. So it says that we take the sum of the values obtained from items A through C for the largest welder in the group and take 60% of everything else. In other words, we had to use the calculated numbers when we went and calculated the branch circuit conductors based on the derating value. We have to find the largest of those numbers and then take 60% of everything else. So if we go back to that calculation, I think I had it here, our largest calculated value, let's go like this a little, whoops, this guy. If we take a look at this, here's our calculated values, you guys. So we have welder 1, 2, and 3. Which one has our largest calculated value? Welder 2. Okay, here's welder 2. So we have, here's a calculated value, here's a calculated value, here's a calculated value. Our largest calculated value is 114.13. So what it's saying is, based on that process, find the largest one, and then take 60% of everything else. So that's what we're going to do. We're going to take 114.13, and that's at 100%, so we could do this. And that equals 114.13. Then it says take 60% of everything else, which is, and I put this in brackets, 108.7 plus 59.78. And we're going to do this times 0.6, which is 60%, and that gives us 101.088. So our total is 215.22 amps. Okay, now if we go to table 2, that is a 4-rod, that's correct. And that's good to 230. Now, I want you guys, you see this process right here? Those calculated numbers are going to come in, right coming up next, are very, very important. Okay, because our next job, now that we size the conductor, is to size our feeder over current device. Now, let's take a look at the rule. I'm just going to insert another page here. Actually, let's go back to, I'll insert a blank page and we want to put some numbers in. So if we go back to here, we know that our feeder conductor is a 4-rod. Okay. Now, going back to feeder over current, so this is number 4. We'll look at our feeder over current device. Now, if you guys take a look at, on page 208, sub-rule 3 from rule 42-016, it says, the maximum rating or setting of an overcurrent device protecting a feeder supplying a group of resistance welders shall not exceed a value calculated by determining the maximum rating or setting of overcurrent device permitted by sub-rules 1 and 2 for the welder allowed the highest overcurrent protection, and adding to this value the sum of the ampacities as calculated by 42014. Okay, so not unlike yesterday where we were talking transformer arc welders. In English, what that's saying is we want to use the same process that we used as far as the derating values for the feeder conductor. We're going to use that same process to size our overcurrent device here, and we have to find the largest welder in the group first. Now, here's the deal. This is where it gets a little tricky. Which one's the largest welder in the group? Well, I have two of them here. Now, when I say largest welder, it says largest overcurrent device. Where's the largest overcurrent device here? We have two of them. We have a problem, don't we? Two of them are rated the same. No, but I like the way you're thinking. So, here's the goal when you run into this situation. When you have a bank of welders and there's 10 guys in a welding shop and they're welding, you want to have the largest possible overcurrent device feeding that bank of welders. Because if they're all welding at the same time, you want to be able to go as long as possible before you run into a problem where you have an overcurrent or an overload condition. So knowing that we have to take the first welder, whatever the rating of this device is, so we already know that our first number is going to be 350, okay, at 100%, right? We know the number is going to be 350. The question is, which welder do I select here that when I multiply the second one by 60% will give us the biggest number? So do I want to use the calculated value from welder 2 or welder 1? We want to use the calculated value from number 2, because which one was the largest calculated value? Let's go back and take a look. 2 was, right? Where's our oh, that's feeder conductor. Where were we? Right here? Okay, here's our calculated values. Welder 1, welder 2, welder 3. So the goal here is we know that welder 1 and welder 2 have a 350 amp overcurrent device. So we're going to use one of those two as our first 100%er. The question is, when I multiply by 60, if I multiply 108.7 by 60 versus 114.13 by 60, which will give us a bigger number? The 114, right? So in this case, we're actually going to use the largest overcurrent device from welder number 1. I think several of you said that, which would be correct. And then we want to multiply the 60% of the last two remaining values. We're going to use welder 2 because it was a bigger calculated value. So that's how you deal with that. So let's work through this and see what we come up with. So, all right, I thought I had a spare page already for that. Guess that was oh, here we go. Here. Okay, so our feeder overcurrent device, welder 1. Welder 1 is the one we're going to use with our 350 amp overcurrent device. It says we take the largest device, which is 350 amps from welder 1. We take that at 100%, plus we use the process, or they use the words as calculated in 42014. So we're going to do this. And I just do it all in one, you guys bracket. So now we're going to take 114.39 plus the 59.78. We're going to times that by 0.6 and end bracket. And if we've done that correctly, that will come out to 454.35 amps. Now again, the rule says we can't go past that number. So based on that, what would we select as an overcurrent device here? 450. Right? So this would be a 450 amp breaker. Make sense? Any questions on why we calculated the numbers we did? Because that's, you're going to come across this often. Go ahead, Chris. Calculate number for which part? Are you talking the last calculation we did?
Yes.
Yeah, no problem. Where were we here? Let's see here. I'm just give me a second here, Chris. I am just gonna stop recording here. Just